In today's lab, we're going to use recrystallization to separate the two solids from a mixture. Acetanlide is a white solid, it's less polar and neutral compound. Methyl orange is an orange solid with an ionic bond which is more polar and more soluble in a polar solvent. We're going to use water as our solvent in today's experiment. We mix these two solids and use water to separate them. They have different solubility in water. Acetanlide is selectively soluble at a higher temperature. The solubility of acetanlide in water depends on temperature. At a higher temperature, acetanlide is soluble in water. At low temperature, acetanlide is not soluble in water. So let's say insoluble in water. So this is the key. We're going to use this property, the physical property, as our key factor to separate these two solids. On the other hand, methyl orange is soluble in water at all temperature. So let's write soluble in water at all temperature. Right. So we use the hot water to dissolve both, and then we cool down the solution to selectively crystal out, right? Crystal out the insoluble acetanlide, and then we do a filtration to separate the crystal from the solution. To add complexity, I'm going to add another, maybe two more substance into this mixture. The third one and two are here. The third one is sand. Right? I'm going to add sand to this mixture. What do we know about sand? Solubility of sand in water. Sand is insoluble in water at all temperature. Right? Here we have acetanlide, soluble in water only at a high temperature. Methyl orange, soluble in water at all temperature. Sand, insoluble in water at all temperature. And I'm going to add one more substance, that is charcoal. Charcoal helps to absorb this methyl orange. So it helps removing this dye. Methyl orange is a dye, right? It's a color dye. So let's write dye. And it has a lot of pi bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are a lot of pi bonds. And charcoal is nothing but a carbon, right? Activated carbon, charcoal, can absorb AD, right? AdSORB, absorb the colored compound. The colored compound absorb on the charcoal. You can see that the charcoal is used in water filter, right? It helps absorbing the larger organic molecules like this. So at the end, we're going to purify acetanlide from the mixture of 4, right? 1, 2, 3, 4 substance in our mixer. They're all solid. We're going to dissolve them in hot water and change the temperature. Do a couple of filtration. At the end, we're going to purify. We're going to get a pure acetanlide, a white color substance, and we check the melting point to verify our product. Right? Let's go to lab. Okay, I'm going to take about 1.5 grams of impure acetanlide, which contains acetanlide, methyl orange, and sand. Right, so let me let's call it 1.551 grams. 1.551 grams. You need this weight for the calculation. Okay, I'm going to transfer this impure acetanilide mixture into this Erlenmeyer flask. Okay, here's the impure acetanilide in the Erlenmeyer flask. I'm going to add a magnetic stir bar. On the side, we have the solvent for recrystallization. In this case, it's water, boiling water. Right? I'm going to add some boiling water to our mixture to dissolve everything except sand. The methyl orange and acetanilide are soluble in hot water. So let's add the hot water. Okay, I've added the hot water, but to increase, to improve the dissolving of our mixture into water, I'm going to stir the magnetic stir bar in the flask by putting the flask on the hot plate. The heat and the stirring will help dissolving our acetanilide and methyl orange into the solvent water. Sand is not going to be dissolved. Right? So let me move this out, lower the temperature, and use tongs to put this on the hot plate. I'm going to stir this. Right. You don't need to measure the volume of the water. You can add as much you want, but don't add too much. That will not help the recrystallization process. Okay, I'm going to zoom into that. You can see that most of the acetanilide and methyl orange are dissolved, and you only have sand in the bottom, right? An orange solution, and there is sand in the bottom. We're going to add some charcoal, activated charcoal, to this. So let me add a pinch of activated charcoal. Again, the purpose of that is to get rid of some of the methyl orange impurity. In this experiment, we consider the methyl orange as an impurity, and our acetanilide is our desired compound, so we call that a pure substance that we want to extract. Okay, so there's some charcoal. I'm going to stir a little bit. Now on the side, I'm going to prepare a filtration setup. Take a filter paper, fold it, right. Right. The fluted filter paper is just one layer, and it can fit into this funnel. Okay, the solution is hot and most of the substance are dissolved except sand. I'm going to filter this. So it's bumping when you heat too much. I'm going to add some hot water to this flask to rinse out the mixture. You can see that it's still dripping. I removed the filter paper, sand and charcoal and trashed them, but some of the acetanilide crystalled out here in the funnel, and it clogged the funnel. And this is the reason why we don't want to use a funnel with stem. If you have a stem, it will cool down the solution faster, and the acetanilide will crystal out and clog the stem of the funnel. All right. Okay, let me add some hot water to rinse the funnel. And once we got all of our acetanilide and methyl orange, I'm going to move this flask into the ice bath. This will selectively crystal out acetanilide, our desired compound. Okay, after about 10 minutes of cooling in the ice bath, we got nice crystals in the bottom, that is acetanilide, and we have the methyl orange that is still dissolved in the liquid water. We can separate the solid from liquid by doing a vacuum filtration. All right, so let's place the filter paper, turn on the water. The vacuum is basically created from the aspirator, right? From the water hose. Turning on the water creates a suction here, right? Creates a suction here. I'm going to add some ice cold water to wet the filter paper and add this cold solution on top of that. We still got some color, a tint of orange on the side. We can try adding ice cold water on the side to get rid of the color, but that will risk losing our compound. Right? We don't want to lose our acetanilide. Okay, after about 10 minutes of drying in the vacuum filtration, I'm going to stop the filtration, remove this dried acetanilide, transfer onto a pre-weighed or tad weigh paper. I zero down the weigh paper on the weigh scale. So let's transfer this. On the weigh paper and remove the filter paper. The filter paper, and that's our pure acetanilide. It's not 100% white. I have some tint of orange there, but let's check the weight. Okay, the weight of acetanilide is 0.163 grams. The purified acetanilide weight is 0.16, I think it's 0.164 grams. Okay, the next thing is to check the purity of acetanilide using melting point. I'm going to do that off the record and post the melting point value on the blackboard. But note down this weight. We got this much acetanilide from the initial 1.55 something grams of impure mixture.